Hello guys, welcome back to Maths on African Motives, still on our revision for mathematics and for working on the differentiation, which is the derivatives in this case from the question paper of August 2023 exams. So we shall quickly rush through the questions that we are given so that we'll see how we're supposed to attempt such typical questions on our derivatives. So 4.1, it was application of the first principles. Okay, differentiate with respect to x from first principles, given f of x, which is equal to 3x to the exponent of 3. So that was our question in this case. Let's see how we're supposed to attempt that typical question in this case. So as we are given from first principles, and this is given as f of x. So we are given our f of x, which is equal to 3x to the exponent of 3 in this case. Okay. Remember that from your first principles, what you need to apply is the formula for the first principles. There's no way we need to have our formula. Yes, we can differentiate direct from the general rule, just is to know the answer that you're going to have at the end, but you are supposed to apply this from your normal derivatives, that is from the formula, whereby we understand that the first derivative with respect to x is going to be given as a limit as h is approaching to 0 of f of x plus h. So you're going to have f of x plus h minus f of x everything over h. So this is what you are supposed to have. Or it can be given as the y dx is equal to, it's one and the same thing. So as you can see from our formula, there is a need for us to obtain f of x plus h. We have our f of x, but we are going to need f of x plus h. And I also explained that you can also determine everything, simplify this whole part here stage by stage. All right, so let us start by determining f of x plus h. F of x plus h simply means where there is x, we are going to substitute x plus h. So it's going to be 3 into that's x plus h to the exponent of 3. So it's either you're going to apply your binomial theorem in the expansion, but if you're given an exponent of 3, you can just have two brackets. Remember that x to the exponent of 3 is the same as x times x squared. So even if you have a bracket, in this case, it simply means we've got 3 into x plus h into x plus h to the exponent of 2. We multiply this a 1, so we're going to add 1 plus 2, which is going to give us a 3. So it's one and the same thing. So choosing this is best because from our identities of algebra, this is an identity actually that you're supposed to know, the expansion of a plus b squared. Remember, I said this is a squared plus 2ab plus b squared. If it is a minus here, we are going to have a minus there. All right, that is the only concept that you're going to apply. So if you're given x plus h squared, it means we're going to expand it this way. So the first part here, we can expand here this bracket by 3, which is outside of the bracket. So it's going to be 3 times x, which will be 3x, 3 times h, which is going to give us 3h in this case. All right, then if we expand this, we are going to have a squared, which is x squared. So we're going to have x squared plus 2 times a times b, which is 2 times x times h. So we're going to have 2xh, all right, plus b squared, which is our b's h. So it's going to be h squared. Okay, so you can expand the bracket in this case stage by stage. We've got 2 brackets, so 3x is going to multiply everything. We're going to multiply this by 3x, we're going to multiply this by 3x, we're going to multiply this by 3x, each and every part. So if we multiply 3x times x squared, this will be 3x to the exponent of 3, all right, plus 3x times 2xh. So if you multiply x and x, it will be x squared. So it's going to be 6x squared h. Then we've got 3x times this h squared. So it's going to be 3x h squared. Just going to combine with h squared in this case. All right, we move on. We are done with 3x. We have got 3h. So 3h is going to do the same thing. Multiply here, we multiply here, we multiply here by 3h. So that is going to be 3h times x squared. So this would be, we're supposed to write as 3h x squared. So it's the same as, since we have other part with x squared at the first part. So we're going to have this as 3x squared h, all right, which is one and the same thing, actually, just one and the same thing. All right, so we have the same thing. The 3h is going to multiply here. So the h and the h is going to give us a squared. So meaning to say here, we're going to have 3 by 2, which is going to be 6x. But h and h is going to give us h squared, all right? Then 3h is going to multiply h squared. So this is going to be 3h to the exponent of 3. All right, so that's it. We can simplify collecting like terms. All right, so we're going to have our f of x plus h, which is equal to which like terms? We've got 6x squared h, and here we've got 3x squared h. So the same exponent, h having also same exponent. So these are what we refer to as like terms. So you're going to add 3x squared. The first term, we do not have a like term, so we are going to combine these two in this case. So 6 plus 3, which is going to give us a 9. So we're going to have 9x squared h. So the like terms must be of the same letter and also having the same exponent, which is the same thing that we are seeing here on 3x h squared and also 6x h squared. The x and the x having same exponent, the h and the h having same exponent. Those are the like terms. We're going to add these two, combine them together. So that's 3 plus 6, which is going to give us 9x h squared. Then we've got the last term, which is 3h squared. This one is not having any like term, so we're just going to write as it is, just like 3x. All right, this is 3x to the exponent of 3. Take note here, to the exponent of 3. Okay, just like the part of 3x to the exponent of 3. These are not like terms. This is x and this is h, so you cannot add these two. So I explained before that it is best that you just simplify everything at once. Find, as you can see from our formula, we are going to need f of x plus h minus f of x. So we can simply obtain this here. So let us have f of x plus h minus f of x. So what does it mean? We are simply going to subtract our f of x, which is 3x to the exponent of 3. So if we subtract here 3x to the exponent of 3, what does it mean? It means 3x to the exponent of 3 minus 3x to the exponent. This will cancel. So we are going to remain with this part, all right? So you can simply calculate this aside, it's fine. So at the end, we are going to obtain, we subtracted this part and this part. So we're going to have 9x squared h plus 9x h squared plus 3h to the exponent of 3. If you understand this idea of working these aside, it's going to be a better introduction for your mathematics and 5, because that's how you're going to be actually working all or almost everything, because you'll be working with a lot of algebraic terms, so you have to at least simplify them aside. All right, so as you can see, also on our formula, we also have here divided by h, whereby we're having f of x, everything that we obtained, then divided by h. So it means in this case, our f of x plus h minus f of x over h. In this case, if we are to divide by h, we are going to have, all right, remember, this is our f of x plus h. From this calculation here, we obtained our f of x plus h. But since we are to divide by this h here, we can just factor out h because h is common. So let us factor out h. So if we factor out h here, we are going to have 9x squared. Factor out h, there are 2 of them, so we're going to remain with the 1h. There are 3 of them, so we're going to remain with the 2 of the h's in this case. All right, so that's it. Everything over h. So we're going to have this whole part over h. So what's going to happen is that we're going to cancel h and h in this case. So it means the whole part of the limit, the whole part of our expression in this case, sorry for that, is going to be given as from this part here. That is what we obtained on or finding of f of x plus h minus f of x over h, which is the part that we are having here on this part. We obtained the whole of this part. So it simply means our first derivative with respect to x is going to be equal to the limit as h is approaching to 0. We simplified everything here. This is what we obtained here. So we are going to have 9x squared plus 9xh plus 3h squared. So this is what we are going to have at the end, plus 3h squared. Remember, we canceled the h and the h in this case. So we no longer have this h. So that means the whole part of this expression can be simplified, or you can simplify it aside, which is fine. Or you can substitute back onto the formula. It's one and the same thing. So now we can apply the limits to say, therefore, if we are to apply the limits wherever there is h approaching to 0, we are going to have a 0 here. We are going to have a 0 here. So at the end, we are going to remain with our answer as 9x squared. So this is going to give us 9x squared. So that is the first derivative with respect to x. So it can be given as dy dx, which is one and the same thing. It's the first derivative with respect to x. But as long you are working with the first principles, you need to use the formula. And also on the expansion, like I said, you can also apply or use the binomial theorem to expand whatever that you're given. All right, let us check the other part of our question, which is 4.2 on the application of a function. So if we check, we worked with a similar question on our last class. We using that was I think a Pew 2021 exam, but that was the square root of tan. Now they are asking us to calculate for the square root of cot x. In this case, the last time that we did this question, it was from the square root of tan. The idea is just one and the same that you're going to apply. Remember the function of a function I explained, you're also given this or from your formula sheet. All you need is to know which formula to apply. For a function of a function, this is the formula that you are going to have in this case. This is for the quotient rule. This is for the product in this case, all right? So we are going to use the function of a function formula, which is this one. So as we can see, on our formula, we are given a derivative of y with respect to x, given in terms of u. Why? Because we are going to introduce a function here. Let me just write it down. We are given that y is equal to the square root of cot x in this case, which is the same thing as writing as the cot of x to the exponent of a half. This is one and the same thing. So to apply the function of a function, we are going to introduce a function in terms in a way there is another function where there is cot x. We are going to introduce a function, and that function must be u. So let u be equal to cot x, so that we'll be able to apply the formula that we are given, that the derivative of y with respect to x must be equal to dy du times the derivative of u with respect to x. Where is this actually coming from? Since we have introduced u in this case, that u is the same as cot x, we are going to have something of this nature. U is equal to cot x. But rewriting our y with respect to u, we are going to substitute where there is cot x. We are going to substitute u in this case. So we are going to have y is equal to u to the exponent of a half. So that is where we are going to have the derivative of y with respect to u in this case, and also the derivative of u with respect to x, that is u with respect to x. So that is what we are simply having. So let us find our derivative, then we substitute into the formula. So from this one, we are going to have the derivative of u with respect to x. So the derivative of u with respect to x is going to give us what? We are differentiating a cot. We must know this, that a cot gives us a negative cosec squared, or you can check from your formula sheet that the derivative of cot here is going to give us a negative cosec squared. So we are going to obtain negative cosec squared in this case. All right, so that's negative cosec squared x. Then we find the derivative of y with respect to u in this case. That's here. We are simply going to drop the exponent, which is a half. Remember here, we're going to multiply, then we subtract 1. So that is going to be after times 1, which is a half u to the exponent. If we subtract half minus 1, that is going to give us a negative half. You can just use your calculator. So you can write this in simplest form. Remember, to the exponent of a negative means 1 over. So you're going to have 1 over u to the exponent of a half. And we know that u to the exponent of a half means the square root of u in this case. So that is the simplification that we can leave in terms of the derivative of y with respect to u. But on our formula, with the one that we wrote for the derivative of y with respect to x, we said we are going to have this from our formula. The derivative of y with respect to x is going to be given by the derivative of y with respect to u times the derivative of u with respect to x, whereby we are going to substitute what we have calculated from dy du, that is the derivative of y with respect to u. We got 1 over 2 square root of u times the derivative of u with respect to x. The derivative of u with respect to x, we obtained negative cosec squared x. So that is what you're going to have. But since we are to find the derivative of y with respect to x, our answer is supposed to be having x, not to be having a u. So we're going to substitute back the u that we said u is equal to cot x. So in place of u, we are going to substitute cot x in this case. So therefore, our answer is going to be 1 over 2. Remember, u here it's the cot of x, all right, under the square root, then times negative cosec squared x. This is same as over 1. So you can combine the numerators together since this is a multiplication. So therefore, the derivative of y with respect to x is going to be given as what? You can multiply 1 times negative cosec squared. That will be negative cosec squared x over 2 square root of cot x times 1 is going to be 2 square root of cot x. All right, so that is how we could have simplified our question on this derivative from our function of a function or the chain rule. All you need is to know the steps that are given on your formula. So that was 5 marks for that. Then 4.2. We are given to differentiate with respect to x. All right, so this is with respect to x in this case, whereby we are given y is equal to 2 to the exponent of x. So as we can see, this one is directly everything is directly given. So all we just need is to differentiate. Remember, I said the derivative of ka to the exponent of f of x. I've always talked about this, that this is k times the first derivative of x times a to the exponent of f of x times the ln of the base, which is the ln of a in this case. So if we are given 2 to the exponent of x, this one is straightforward. The derivative of x, here the constant is 1, so it's just going to be a 1 times the first derivative of x there, which is a 1. Then everything remains as it is. So it's going to be 2 to the exponent of x times the ln of the base, which is the number that you're given as 2. So 1 times 1, that is 1. So as you can see, this one it just remains as it is. So it's going to be 2 to the exponent of x ln of 2. All right, so this formula is best to use on the e, where there is an e there, we shall see this one, and also on this, okay, that one is a constant, so we're not going to apply it. All right, let's move on to the ln. From our formula sheet, the derivative of ln is 1 over x. So meaning to say we are going to have 1 over 2 pi times the derivative of ln, which is going to be 1 over x. So you're going to multiply, in this case, 1 times 1, which is going to give us 1 over 2 pi times x. So it's going to be 2 pi x, all right? Then e, in this case, all right, we are back to the exponent condition, where I say the derivative is going to be the constant, which is our constant, that's a half in this case. So we're going to have 1 over 2 times the first derivative of x. So this is our f of x, which is 3x. So the derivative of 3x, that's a 3 times a to the exponent of f of x, meaning to say this function is going to be written as it is, 3 to the exponent of 3x times the ln of the base, which is ln a. The base, which is e in this case, is going to be ln e. And I told you guys that ln E is equal to 1. So simply meaning you are going to multiply a half times a 3. So half times 3, that is going to be 3 over 2. So you're going to have 3 over 2 e to the exponent of 3x. Yes, you can write the ln E, but know that the ln E is equal to 1. So you can simply leave it like that. All right. Then let us move on to the last part. This one, we do not have x. Remember, it's with respect to x, and we do not have x, meaning to say x, this is a constant, and the derivative of a constant is going to give us a 0. So we are not going to have anything. So that's it. This part is marked each stage. Each part is having a mark. So you're supposed to indicate each and every part so that you obtain the 4 marks that you see there. That is how you answer this typical question. Then you're asked to determine the coordinates of the turning points with the aid of differentiation from this cubic expression, whereby we are given y is equal to x to the exponent of 3 minus 2x squared minus 8x. All right, so this is 8x. All right, so let's see. This is what we were given. We're asked to determine the coordinates of the turning point. That is the first question. We shall talk about to indicate maximum later on. Let's talk about being the turning points in this case. What is the condition that we are going to apply at the turning points? Remember, at the turning points, at any turning point, whether it's a maximum or it's a minimum turning point, as long you're talking about turning points, the first derivative must be equal to 0. Whether we are given it in terms of f of x, the first derivative with respect to x must be equal to 0. So that means dy dx from this cubic expression must be equal to 0. So we are supposed to find the derivative of y with respect to x. That's 3 here, going to multiply, which will be 3x to the exponent of 2. Then on 2, going to multiply 2 times negative 2, that's negative 4x. Subtract 1, so it will be negative x. Negative 8x, this will be a negative 8. So this is our first derivative, which must be equal to 0. So you're going to form an equation now. That's 3x squared minus 4x minus 8 must be equal to 0. So it's either you're going to use your quadratic formula or factorization, but as you can see here, we do not have factors. So the best part was to apply in this case was to use the quadratic formula where x is equal to negative b plus or minus the square root of b squared minus 4ac everything over 2a. All right, so it's just a substitution. We've got our a, our b, and c. So our a there is equal to 3. Our b is equal to negative 4, and our c is equal to negative 8. So we're just simply substituting into our quadratic formula in this case. All right, so let us substitute and see what you're going to have. So we are going to have x, which is equal to negative b, so that's our b, which is negative 4, plus or minus the square root of b squared, which is negative 4 squared. So it was supposed to be negative 4 squared minus 4 times a, which is 3, times c, which is negative 8. All right, so this whole part is divided by 2 times a, which is 2 times 3. So if you are to solve this, you're going to obtain 2 possible values of x, which is first value. If you consider a positive, you're going to obtain 2,4,3,0,5,0,0, which is going to be 3,1 in this case. Or the other value of x, if you consider for a negative, you are going to obtain your answer as negative 1,097. All right, so these are the values of x at the turning points. So in order for us to obtain the values of y at the turning points in this case, you are simply going to substitute the value of x as it is into the original equation. Remember, our original equation is y is equal to this. So we are going to substitute the value of x as it is to find y1. Remember, x1 was 2,431. So in place of x, we're going to have 2,431 to the exponent of 3 minus 2 into 2,431 to the exponent of 2 minus 8 into 2,431. So you have to substitute each part. So there you're going to obtain negative 16,901. All right, so that's negative 16, we've obtained negative 16,901. You do the same thing for the y value which is when x is negative 1,097, you are going to obtain 5,049. So this is these are our turning points. We've got the first turning point, which is given as x 2,431, then the y value at negative 16,901. And the second turning point in this case, given at x being negative 1,097, the value of y being 5,0, that's 5,049. All right. So these are our turning points. That was the first question, just to determine the turning points. But this is not everything about our question. After determining these turning points, they are now saying, and indicate maximum and minimum turning points using the second derivative as well as the point of inflection. All right. So we need to determine whether it is maximum or minimum, which turning point that we have here that is going to be maximum and which one is going to be a minimum. All right, so in order for you to tell whether the turning point is maximum or minimum, you work with the second derivative. So for maximum and minimum turning points, you are going to work with the second derivative. Use the second derivative in this case, right? So you're going to use the second derivative. What is it that we are going to use on the second derivative? If you find the second derivative with respect to x or the second derivative with respect to x in this way, and this value is greater than 0, it's a positive. It means that point that you used, it's a minimum turning point. If you use the same condition for the second derivative with respect to x and you find your value being less than 0, which is a negative, it means at that point, it's a maximum turning point. So meaning to say we are going to need the second derivative from the first derivative. Remember, we obtained our first derivative here. This was our first derivative, the derivative of y with respect to x, which is 3x squared minus 4x minus 8. So we are going to take our first derivative, the one that we obtained, then we differentiate again. All right, so remember it was 3x squared minus 4x minus 8. Therefore, we find the second derivative with respect to x, which is going to be 3 by 2, which is 6x minus 4. That's a 0, which is a constant, all right? So this is our second derivative. In order for us to tell that this point here, the first turning point, is minimum or maximum, we are going to need the x value at the turning point, and our x value is 2,431. So we are going to need the x value at that turning point, right? So this is what I'm trying to say. We are going to test using the x value at that turning point. So at the first turning point, our x is 2,431. So we're going to substitute into the second derivative. So it's going to be 6 into x, which is 2,431 minus 4. All right, simplify and see what you're going to have. That is to tell whether it's negative or it's positive in this case. So this was going to give us 10,586, which is a positive value. And like I said, if you obtain a positive value or a value that is greater than 0, it means that point, it's a minimum turning point. So it means where we obtained this value from the first turning point and gave us a positive value, that point, it's a minimum turning point. So this one, it's a minimum turning point. Okay, we do the same thing, but as you can see, it's a cubic function. So if one point is minimum, the other one is maximum. But anyways, we're supposed to prove by derivatives. So for the second turning point, our x is negative 1,097. So you're going to substitute in place of x on the second derivative. So it's going to be 6 into negative 1,097 minus 4. So if we simplify, we are going to obtain a negative in this case. That was negative 10,586 0.582, something like that, which is a negative value. At a negative value, it means the second derivative is less than 0, and that point must be a maximum turning point. So it means our second turning point is a maximum turning point. That is the condition that they are asking you to do. You work from the second derivative to determine whether this is minimum or maximum from this idea of our second derivative. All right, so that was our question on determining. Then also it was to find the points of inflection in this case. All right, so we're going to need the point of inflection. So the point of inflection is also from the second derivative, but how do you determine the point of inflection from the second derivative? It follows that for the point of inflection, the second derivative with respect to x must be equal to 0. So we are simply having the second derivative directly equal to 0. So that is the condition for the point of inflection. So the second derivative, we have it, we obtained our second derivative, which is 6x minus 4. So it must be equal to 0. So that means we have formulated an equation whereby you are supposed to solve for x. So if you transpose 6x, negative 4 to this side, if you transpose, it's going to be a positive 4. Divide by 6 by 6, so that will be 2 over 3. So x is going to be 2 over 3. So we have the value of x at the point of inflection. So in order for us to have the y value, we are simply going to substitute the x value, which is 2 over 3, into the original equation for y. Remember, from our original equation, y was given as x cubed minus 2x squared minus 8x. So you're going to substitute wherever there's x, you're going to substitute 2 over 3. So you're going to have y is equal to 2 over 3 to the exponent of 3 minus 2 into 2 over 3 to the exponent of 2 minus 8 into 2 over 3. So that was going to give us negative 160 over 27 in this case. So it was going to be over 27. All right, so that is it. Our point of inflection in this case, we simply have to use the second derivative, but the second derivative must be equal to 0. That is how you determine these from your derivatives. You can determine the turning points and also determine their nature to say, is it maximum or is it minimum? And also you can determine the point of inflection from the derivatives. Again, you can use that to determine the point of inflection. So these are the typical questions that you'll be given on your final examinations.